Welcome back to the GCSE Maths Pro YouTube channel. Today's video is a compilation of everything you'll need to know about simultaneous equations as a higher tier student. So as you can see, we'll be basically covering three different parts of the topic. The first two are to do with the actual algebraic solving of the equations, and then finally we'll have a quick look at how to solve simultaneous equations but on graphs. If you feel that you would like to look at any of these topics in more detail or see more questions, I will link down below all of the individual videos for you to check out. So first of all, the question will probably say, solve these simultaneous equations. So the elimination method is one of the two methods you can choose to use to solve these equations. So just with looking at equations in general, the bit that makes them simultaneous is the fact that whatever the x value is for the first equation is the same x value for the second equation, okay? So when I find out what x is, it's the same for both. Okay, and when I find out what y is, again, it's the same for both equations. The elimination method, it's kind of in the name, we're going to eliminate one of the letters first. So you're going to have a little look at your simultaneous equations. You're going to see, right, okay, we're going to focus on the coefficients of x and y. The coefficient is the number in front of the letter. So for example, 4, 7, and this is -2 and +2. These are all coefficients, right? You're going to check, do I have the same number of x's or the same number of y's? In this case, yeah. We have the same number of y's, don't we? They're both 2y. If you have that, eliminating kind of means make it 0, isn't it? Cancel it out, right? If I've got 2y and 2y, well, I can cancel those out to make 0, can't I? The first bit is you need to decide which letter do you want to eliminate. Now, this is a choice. You can choose either x or y. However, there's normally an easier option, right? So, looking at the coefficients, which ones, either x or y, would be the easiest to make 0? Now, in this case, the easiest route would be to eliminate y, because they're both already 2y, they're the same quantity. Doesn't matter if they're plus or minus at this point, we're just looking purely at the number in front of the letter. So in this case, I'm going to choose to eliminate y. Step number 2 is you have to figure out, okay, well, how do I eliminate y? By either adding or subtracting the two equations. Obviously, we always take the symbol in front of the letter as well, don't we? So in this case, it's not just 2y, it's -2y, and this one is plus 2y. You might be able to figure that out just by thinking about it, or if you're not sure, there are acronyms that you can use to help you. So we have SSS, which means if you've got the same sign or the same symbol, you subtract. So if they're both plus or if they're both minus, you have to subtract the two equations. Or we've got the other one, which is DSA, which means if they're different signs, so one's a plus, one's a minus, you have to add the equations. So in this case, you can see I've got a minus and a plus, so I need to add the two equations. So I'm just going to draw a line underneath and put plus. Now, it is algebra, right? So you can only add together like terms. So in this case, I'm just going to go through column by column. So 4x plus 11x, how many do I have? Well, I've only got there 11x. Okay, now the next bit should make 0, right? That's the whole point. Minus 2y plus 2y makes 0, doesn't it? Okay, good. They cancel out. I've eliminated y. Equals, and then I've got 14 plus 19, so that should give me 33. Do you see how now I've got an equation with only one letter, just x? Again, it depends which one you decide to eliminate. You might end up with an equation with just y. That's fine, as long as you've got an equation with just one of the two letters. That's the aim. Now that we're at this point, you're just going to solve it like a normal linear equation, aren't you? So solve the equation. When we want to solve a linear equation, we want to get x or whatever letter it is just on its own, don't we? Well, the 11 is in the way, isn't it? I don't want 11x, I just want 1x. So the opposite would be to divide by 11. So 11x divided by 11 is obviously just 1x. And 33 divided by 11 is 3. Okay, perfect. So I've already got one answer here. I eliminated y to find x. X equals 3 for both equations. Once you've done the first 3 steps, the last bit is much easier. Step 4, you basically want to then take this value and substitute it back into one of your two original equations. It doesn't matter which one again, you just look at both and decide, do you know what, like the first one is easier, the second one's easier. substitute the value that you found. It might be x or it might be y, but in this case it is x. You substitute the value back into one of the original equations. So I'm personally probably going to choose, I might choose the second equation because at least there's no negatives, but you can choose whichever. So 7, now instead of x I'm going to write 3 because I know it's 3, isn't it? Plus 2y, which I still have, equals 19. This is my point. Do you see how now we've only got y in the equation? And I guess step 5, if you want to call it step 5, is to solve the equation again. Solve the equation to get y. 7 times 3 is 21, plus 2y equals 19. Okay, it's currently positive 21, isn't it? So the opposite would be to subtract from both sides. So I get just 2y. 19 minus 21 is minus 2. And then I will just need to divide by 2 because I just want 1y, not 2y. So y equals minus 2 divided by 2 is minus 1. There you go. There's your second solution, and then you have finished the question. So our answers are x equals 3 and y equals minus 1. Okay, so this one is a little bit different, only because now we're going to take a step up and make it a little bit harder. If you have a look at our two simultaneous equations, you're going to see that now we don't have the same number of x or y, for example. The coefficients are now no longer the same. Now we have to apply it to something a little bit harder where we've got to add an extra step at the start in order to create that scenario where we do have two of the same letter. So this is where you've got another decision to make. You've got to look at these equations and go, do I think it's easier to make the x's the same number, the same quantity of x's, or the y's the same quantity? We're going to be using the concept of the lowest common multiple to find the same coefficient for one of the letters. For example, you're going to look at it and go, okay, well, currently I've got 4 and 2. Ignore the symbols, that doesn't matter, just the numbers. For x, I've got 4 and 2. So the lowest common multiple of 4 and 2, where is the smallest number that they both would overlap? Well, that's 4 itself, isn't it? And then let's say for the y's, so we've got 2 and 5. The lowest common multiple of 2 and 5. Again, if you think about the times tables of 2 and 5, the first time that they overlap is at 10, isn't it? So this is how I'm going to choose, because do you see how if I were to make both the x's the same number, I just have to make them both 4x? Well, that's great because one of the x's is already 4x, isn't it? That means I only have to change the second equation. The first equation is already 4x, it's perfect. However, if I were to look at the y's and make the y's the same, neither of them are currently 10y, are they? Therefore, I would have to change both equations. You can do either. You can make the y's the same or the x's the same. It doesn't matter, okay? It's not right or wrong. So in this case, I'm going to choose to make the x's the same coefficient, okay? So both have to be 4x. So I'm going to label them equation 1 and equation 2 again. Equation 1 is perfect. Don't need to do anything about that. I might just write it again over here just so we can look at it closer to what I'm about to do. That's equation 1, isn't it? Equation 2, how do I make it into 4x? Well, how do I go from 2x to 4x? What do I need to multiply by? Well, I have to times by 2. I can't just times this by 2 and make 4x, because then it wouldn't be the same equation, would it? I have to multiply the whole of equation 2 by, in this case, 2. So equation 2 multiplied by 2, we get minus 2x times 2 is minus 4x. Okay, they're both the same now. We get 5y times 2, which is 10y, and we get 29 times 2, which gives us 58. Now, if you want to call it equation 3, you can, it's up to you. Now I've got these two, we can kind of ignore the other two equations, okay? Now I'm back to the same steps as we took before, okay? We've just had to add in this additional step at the start, haven't we? From now, I'm going to do the same thing. So I'm looking at my 4x's, obviously that's what I'm going to eliminate, isn't it? So you have to choose. Same sign subtract or different sign add. How am I going to eliminate the x's? Well, if you have a look at the x's, and again, it's the symbol in front of the x's, right? We're not looking at the pluses, okay? That's to do with the y's. We've got positive 4x and negative 4x. Okay, that means different sign, right? 1 plus, 1 minus. So different sign, add. So I have to add my two equations together in order to get rid of or eliminate the 4x, right? Because you've got 4x plus minus 4x, that makes 0, doesn't it? Perfect. Okay, then we're going to add everything else. We've got 2y plus 10y, that's 12y. Then we've got 2 plus 58, which is 60. Perfect. Again, we're back to something that looks a bit more familiar again. I've now got y as the only letter in my equation, so all I need to do is solve that equation. So I have to divide by 12 on both sides to get just y on its own. So 60 divided by 12 is 5. Okay, perfect. I've done all of the hard work now. I know what one of my letters is. As we know, the second half to find the other letter is then a little bit easier, isn't it? So I'm going to bring back my other equation so you can see it. But this is where we have to choose which equation do we want to substitute the y being 5 into. Now you can choose 1, 2 or 3. I wouldn't choose 3 because it's just a bigger version of equation 2, right? So if it's bigger, it's going to be more work. I would personally just stick to choosing between equation 1 and equation 2, okay? Just keep it simple. Whichever you think looks easier. I would say equation 1 looks easier. Not only does it have no negatives, but also the numbers are smaller, so that's just my personal choice. So sub y equals 5 into equation 1. So we've got 4x plus 2y. Now I know that y is 5 though, so I've got 2 times 5 now equals 2. Now you can see I've got an equation with just x, so I'm going to solve this. Obviously, first of all, I'm going to times 2 and 5 to make 10. Now I can see what to do. I need to move the 10 across, don't I? So because it's plus 10, I need to subtract 10. 4x equals 2 minus 10 is minus 8. And finally, divide by 4 to get x on its own. Just going to put it over here. So 4x divided by 4 is obviously just 1x. Equals minus 8 divided by 4 is minus 2. There we go. So our solutions are y equals 5 and x equals minus 2. Okay, so we're going to see linear simultaneous equations similar to the ones that we saw in the first video. We're just going to be using a different method. When you have substitution method, you might see it laid out a little bit differently. Okay, so in this case, we've got y as the subject of this second equation, right? It's still effectively the same thing, right? They've just rearranged the letters. If I were to use substitution method, well, okay, it's in the name. The same thing we did with the elimination method is that we have to get rid of one of the letters first, because we cannot solve equations with 2 or more unknown letters, right? So any equations, you have to get rid of one of them first by whatever means you want to, whether that's elimination or substitution. Then you can solve the equation with whichever letter is left. So in this case, when we use substitution, basically, let's say I'm going to label them equation 1 and equation 2 again. I'm going to be having a look at my two equations and decide which one would be easier to substitute into the other one. In this case, it's pretty obvious. The second equation has already got y as the subject, right? So that means I can say, okay, y is the same thing as x plus 3. So for example, in this case, I would substitute equation 2 into equation 1. And what that means is wherever it says y, I'm going to replace it with x plus 3. So equation 1, we've got x plus y equals minus 1. So I'm going to write x plus, now instead of y, I'm replacing it with the equivalent, with what y is the same as. Y is the same as x plus 3. So instead of writing y, I can just replace that with x plus 3. Obviously still equals minus 1. Okay, so I've substituted equation 2 into equation 1. It's up to you which equation you want to substitute into which. It doesn't matter which way around you do it. It's just in this case, it was pretty obvious that one would be easier than the other. So you can see now I've got that whole aim of the game is that I've got only x's, and obviously numbers, but just in terms of letters, the only letter I have is x in this equation. That's perfect. I've effectively got rid of the y temporarily, haven't I? So now all I need to do is solve this equation. Okay, well I'm going to start by collecting the like terms because I've got x plus x. So that can simplify to 2x, can't it? I still have plus 3 equals minus 1. This might look a bit more familiar to you now. It's just a normal equation, isn't it? So I'm going to solve it. I need to get x on its own. So I'm going to move the 3 first. And because it's plus 3, I have to subtract 3. I have to do the opposite, don't I? So 2x, we've cancelled out the 3 equals minus 1. Take away another 3. Be careful with your negatives here. This is just going to get more negative, isn't it? Minus 1, take away another 3 is minus 4. Okay, perfect. Now the last thing is I just need to divide by 2 on both sides. to get 1x. So I'm just going to put it here. 2x divided by 2 is obviously just 1x. And minus 4 divided by 2 is minus 2. Perfect, there we go. I've got my first letter. Now with simultaneous equations, you know by now that we have to find both, don't we? We have to find x and y. It doesn't matter which one you find first or second, as long as you get both what is x and what is y. So now that we found x, that's the substitution part of the method. The second part, when you go to find the other letter, is the same with the elimination method, okay? Same thing. The only thing that changes is this first part. So now that I know that x is minus 2, I can kind of substitute that back in as I would with the other method. You just look at your original two equations and you choose, would I rather put x into equation 1 or 2? It doesn't matter, you just have to choose which you prefer. Personally, I would prefer equation 2 because I've already got y as the subject, and I'm going to try and find y, aren't I? So I don't have to rearrange anything. So I'm going to sub x equals minus 2 into equation 2. So y equals, now where it says x, I'm going to write minus 2 instead, plus 3 is the equation. I don't even need to rearrange that, do I? I just need to literally do minus 2 plus 3, so y equals 1. There we go. I've solved my simultaneous equations. So that's the substitution method. You might think that seems easier. If you do, you can choose to use this one. It really doesn't matter which one you use. I think it was easier because it was laid out this way, but we're going to look at some harder questions where it's not laid out as straightforward as this. So we're going to have a look at how we solve quadratic simultaneous equations. When I say quadratic, I mean that one of them will be a quadratic. So that means that the highest power of x will be x squared. You might also have y squared, but you'll have an equation that has an x squared or maybe also a y squared. The other equation will be linear. So you can see this one here, the second one, y equals x plus 1. They're all to the power of 1, aren't they? They're just linear. It's like a straight line graph almost, isn't it? We cannot use the elimination method that we were using to solve linear simultaneous equations because it won't work. We can't eliminate all the x's, for example. So we're going to be using what we call the substitution method. That is a method you can also use for linear simultaneous equations, but I think most people prefer elimination. Basically what we need to do is you will always get your linear simultaneous equation and you're going to substitute it into the quadratic one. Okay? This is a nice one to start with because we've already got y as the subject. Okay, so that's quite easy to replace this y with x plus 1. Because obviously, being simultaneous equations, these y's are the same as each other, right, in terms of the value of them, and the x is the same. So all I need to do is replace this y with x plus 1 in this case. We will see harder ones where you don't have, for example, one of the letters as the subject, and that will require a bit more rearranging. But let's just start off with a more basic example. So I'm going to label it equation 1 and equation 2. Always substitute the linear, okay, so the easier one, into the quadratic, into the harder equation. So sub equation 2 into equation 1 in this case. As I said, I don't need to rearrange anything, so I'm just going straight into this. So, because y is the same thing as x plus 1, where it says y here, I'm going to write x plus 1. So I'm going to replace it, okay? I'm going to substitute in. So I'm going to rewrite equation 1, but instead I'm going to write x plus 1 where I originally had y, because we know that that is the same thing. And then obviously the other side is still x squared plus 2x minus 11. Now, it's the same logic as linear simultaneous equations, as any simultaneous equations, because we cannot solve an equation if we have more than one letter, okay? We've got x and y in these ones. We can't solve that on its own. That's why we have to have two equations, because there are two letters we don't know. If you had 3 letters, you would need 3 equations, for example. So the whole point is we're trying to get rid of, one of the letters to start with. Normally it doesn't matter which one you get rid of. This one, it was easier to get rid of the y's. You can see now I've got an equation purely with x. That's perfect, because now I can solve it, okay? Now the second bit that's a bit harder, obviously, is that this is still a quadratic equation, right? So in the way that we would solve a linear equation by getting all the x's onto one side and all the numbers on the other, and then you get x equals, it doesn't work that well. If you know that you're going to end up with a quadratic, so you still have an x squared somehow, you're going to have to get all the terms onto one side and the 0 on the other. It doesn't really matter which side, but I personally prefer to choose the side where the x squared is positive. So as you can see in this case, x squared is already positive on the right hand side, so I'm going to personally choose to move my x plus 1 to the other side, okay, so that my x squared stays positive. So in order to do that, I have to subtract x and subtract 1, don't I? Because they're both just added. So I'm going to subtract x and subtract 1, so x squared is still there. 2x subtract x is then just 1x, isn't it? And then we've got minus 11 subtract another 1 is minus 12. So the whole point is I've got a quadratic all on one side and I've got 0 on the other. Now the way that we solve quadratics, there are multiple ways, but probably the most common way is that we're going to have to factorize, and that means put this into 2 brackets. So you still have your 0 here. And again, like I said, this is another thing. We've got to be happy with substitution. We've got to be happy with rearranging. We've got to be happy with factorizing quadratics already. And we're not even past the first point, are we? Effectively, we're looking for 2 numbers that multiply to make minus 12, but when you add them, it makes positive 1. So I've got x and x because it's just x squared, isn't it? 2 factors of 12. Now, multiplying to make a negative means plus and minus, doesn't it? Factors of 12 that when I add them, 1 being plus, 1 being minus, makes 1, would be 4 and 3. And then, because I've got positive 1 overall, I want positive 4 and negative 3. Perfect, so I've factorised it. A lot of people even get to this point and then are not sure how to then solve it. They say, okay, that's great, but what is x? So with quadratics, you're going to end up with 2 solutions for x, and also therefore 2 solutions for y. So the logic here, just going to quickly recap it, is brackets means multiplied, isn't it? We're saying these 2 brackets are multiplied together and they equal 0. That's why the 0 is important. Just think about it in terms of actual numbers. If I multiply 2 numbers together and the answer has to be 0, well then surely one of those 2 original numbers also has to be 0, if not maybe both. Because how else do you multiply 2 numbers to make 0 if you don't already have 0 in there? So the logic is we're saying that one of these brackets must be equal to 0. Could be both. We don't know which one. So I'm going to move it up here so we can see. But you kind of say, okay, well, if the first bracket equals 0, so I go if x plus 4 is the one that's equal to 0. Do you see how now this is just a linear equation? I can solve that normally, can't I? As in, keep x here, move the 4 across. So to move the 4, I have to minus it. 0 minus 4 is obviously minus 4. There's one of my solutions. But I don't know, it could have been the other bracket that was 0. Or like I said, it could have been both. So I go, or the other brackets, x minus 3 equals 0. Again, I get another linear equation. In this case, add the 3. X equals 3. Now, you don't necessarily have to write all of that, but it's just so you can see the logic. You might just be able to look at this and go, oh yeah, I have to just change the symbols. Okay, fine, that works. So I've got my x solutions. Like I said, they're going to be 2 because you've got a quadratic. When we have x squared, we often have 2 solutions. So I've got minus 4 and 3. That's the hardest bit, okay? Now we're going to do the second part, obviously to find, in this case, y. Is the same as when we had linear simultaneous equations. Just once you've got one value, you just sub it back in to find the other one, don't you? So you get to choose, do I want to substitute into equation 1 or equation 2? Again, I would always probably choose the linear one because it's just easier, right? It's already in terms of y and it's just x plus 1. You can substitute it into this x squared plus 2x minus 11 if you want, but I feel like it's a bit unnecessary, isn't it? So the next bit is, okay, we're going to do them both individually. Sub x equals minus 4. Into, again, like I said, I'm going to choose a linear one, so equation 2. So I've got y equals, instead of x, I'm going to write minus 4, and then plus 1, and then I just have to solve that, but basically just work that out, isn't it? Minus 4 plus 1 is minus 3. Okay, great. And then you go, or, and we want to sub x is 3, don't forget to do both, into equation 2. So y equals, instead of x, I'm going to put 3 now, plus 1, so y is 4. And then you should have 2 pairs of solutions. Okay, so you should have 4 solutions in total. X is minus 4, y is minus 3, or x is 3 and y is 4. Okay, and that's it solved. As I said, this is a much simpler example, so you get the kind of gist of the parts and all of the method, but they will make it harder because they probably won't lay it out as nicely as this, right? So that's our first example. Let's have a look at another one. Okay, so now you can see again, we've gone slightly harder with the fact that the linear equation now doesn't have any letters with 1 as the coefficient. So we don't just have 1y or 1x, we have 4x minus 2y is 24. And we still need to substitute that into our quadratic, okay? So equation 1 here is the quadratic, equation 2 is the linear. So again, we're going to have to rearrange equation 2 first to make either x or y the subject. Again, this is just personal choice. if we weigh up the pros and cons, we can see it's probably easier to make y the subject. However, then when I substitute the y in, I have to do not just y squared, but 2y squared, and also minus 2y squared, right? So it's probably easier to make the x the subject for then when we substitute it in. But you can see we're kind of splitting hairs here, so it's literally up to you what you prefer. You might just decide, you know what, every single time I'll make y the subject so I don't have to bother choosing. That's also fine. So I'm going to choose to make x the subject, okay? That's just my personal choice. So I need to move the 2y across, and then I need to divide by 4. So let's just move the 2y across first. So add 2y, and put it before the 24 just so it looks nicer. And then I would have to divide by 4, wouldn't I? Now you can see we are probably going to end up here with a fraction. Just because, yeah, okay, 24 does divide by 4, but the 2 over 4 doesn't divide properly. So I'm going to leave it like this. Now, we can simplify this side a little bit. We can at least divide everything by 2, can't we? We have 2 as a common factor in all 3 terms. So let's just simplify that at least. So we get y plus 12 over 2. Okay, so we've got a fraction, but at least it's fairly simplified. So this is equation 2, just the rearranged version. Now we're just repeating the same process we did before. So we need to substitute equation 2, or whichever is the linear, into the quadratic, which in this case is equation 1. So I'm going to replace the x, okay, with all of this. So instead of x squared, I've got y plus 12 over 2, but remember it's also squared, isn't it? So the whole of that is squared minus 2y squared equals 32. Okay, great, because now I have an equation with just y's in it. I just have to do a load of expanding, rearranging, and solving to get y. So the first thing I can do is expand the brackets here, squaring them. Again, don't make the mistake. It's not just y squared plus 12 squared, okay? It's effectively like double brackets at the top there, isn't it? I'm to write it up over here so we have space. That's the same as writing y plus 12 times by itself, which is another y plus 12. Obviously 2 times 2 effectively, isn't it? 2 squared. So you see we're going to end up with double brackets, okay? So it's not just y squared, it's not just 12 squared, we're going to have the middle terms as well, so just be really careful of that. So when I expand this, I'm just going to do it straight. I'm going to get y squared, obviously plus 12y plus 12y, so that's plus 24y, and then plus 144, because that's 12 times 12, over 2 squared, which is 4. Now I still have the rest, minus 2y equals 32. Okay, if I could simplify the fraction I would, however, the y squared cannot divide by 4 equally, can it? So what I'm actually going to do to get rid of this fraction is just multiply across by 4, because then I can cancel out the denominator. So we're going to times by 4 on both sides. Now also, it's not just both sides, but remember that we have also got this minus 2y squared in the middle. Everything has to be times by 4. So when I multiply the first term, this whole thing is a term, isn't it? Obviously, all it's going to do is cancel out the 4. Okay, the numerator will stay the same. However, I do need to times this by 4 and the 32 by 4. Okay, so these are all tiny little things where everything could go wrong very easily. So y squared plus 24y plus 144, okay, so we've cancelled out the 4, minus, now 2y squared times 4 is 8y squared equals, and then 32 times 4 is 128. Okay, perfect. Now it's looking a little bit better. So as we did before, we know we're going to end up with a quadratic, okay? So we're going to want to get all the terms on one side, collect all the like terms, and have it equal to 0. But specifically, I want it where y squared is going to be positive. And if you have a little look, if we were to collect the like terms, we've got y squared minus 8y squared. That's going to make a negative number of y squareds overall, isn't it? I'm going to get minus 7y squared plus 24y plus 144 equals 128, and that's the problem that I have here. I would rather move all of these 3 terms to the right hand side just to make it positive. So that's my choice. Again, it's up to you. You could do it the other way, but I would rather have y squared as positive. So I'm going to add 7y squared. We need to subtract 24y and subtract 144. Now we already have 128, so you're doing 128 minus 144, which gives me minus 16. Perfect, we've got our quadratic. Now, normally I would say, look if you can simplify it. Obviously, there aren't any common factors, so I can't simplify this any further. I now need to factorize it. I'm going to go up here so I can factorize it. So we're putting the 2 brackets back in. Now, it looks bad. If it is a calculator exam, you can use the quadratic formula if you'd rather. Just be careful of any double negatives. However, 7 is a prime number, right? So at least I know immediately it's going to be 7y and y. There's no other way to split that up. Now we're multiplying to make a negative, so we're going to have a plus and a minus. I don't know which way around it is yet. And then I need factors of 16. So I'm going to use 4 and 4, because they're both 4, it doesn't really matter which way around I put them. Now the plus and the minus, 7y times 4 is minus 28y, and then plus 4y is minus 24y. Perfect. Again, now the way I'm going to solve it is I just take each bracket, make it equal to 0, and then that's this linear equation I could solve. So I just need to subtract 4 and divide by 7. So I've got y is either minus 4 over 7, or, in this case, just add the 4, y is 4. Okay, we've got the first two answers. This is the hardest bit, isn't it? Okay, so you can see there's quite a lot of rearranging at the start, and also subbing in a fraction is a little bit more to work through. But otherwise, the structure of the method is still the same. Now we're on to the last bit. Now we've got the first letter, I just now need to find x. And again, you want to take both of these and sub them back into one of the original equations. However, obviously it's normally easier to sub it into the linear one, but I would actually sub it into our rearranged version. Do you remember we rearranged it? It's still equation number 2, it's still the linear one. But I've already rearranged it to have x as the subject, and when I want to find x, that's what I need, isn't it? So I don't want to rearrange it twice, so I might as well sub it into this equation here, okay? So do them both individually. Sub y equals minus 4 over 7 into equation 2. So I've got x equals minus 4 over 7 plus 12 over 2. I'm going to leave it as a fraction, and as an improper fraction I get 40 over 7. Okay, and you go, or could be the other value, couldn't it? Sub y equals 4 into equation 2. So x equals 4 plus 12 over 2. Okay, that one you can basically work it out, right? 16 over 2 is x is 8. There we go. Both x values, both y values, we've solved it. So let's look at our first question. We're starting off with linear simultaneous equations. Okay, so this is, as I said, for both tiers, but mostly focusing on foundation tier. Linear is when we have straight lines, basically, isn't it? If you look at the equations, the highest power is just 1, right? X to the power of 1, y to the power of 1. They basically create a straight line graph equation. Obviously, it just looks like it's rearranged, isn't it? The straight line graphs, linear graphs, are written in this format, y equals mx plus c, but it could be rearranged. So you can see this. It has all the components, they've just rearranged them. So it says, using the graph, solve the simultaneous equations. They list them here. They're both drawn for you, right? You've got each equation is each different line on the graph. And normally this will be a couple of marks, and they won't really give you any space for working out. Okay, so the two hints here is the fact that it says using the graph, and the fact that on your actual exam you won't see much space to do any working out. So if anything, we don't really even need to look at these equations for this one because it's already drawn for us. All we need to do is look at the graph. Now, simultaneous equations, we've said before, is where you have the x value for both equations is the same number. So we're trying to find what is x. Well, it should be the same number for both equations. And the same with the y, okay? The y is the same number for both equations. So x is the same here, y is the same here. Now, if you think about the graph, we're basically therefore looking at somewhere on the graph where both lines share the same x and the same y values. Now, it has to be at the same time. So really, the main thing about this graph I'm looking at is where do they intersect? Where do they cross over each other? Because that point, exactly in the middle here, is where they both share the same x coordinate and they both share the same y coordinate. Okay, coordinates, values, same thing, right? They're still just what is x as a number, what is y as a number. So all you need to know and remember is that if you get this question, just look on the graph, where do they cross, read off the x, read off the y. Okay, so you can see here we've got x is 1 and y is 3. Now, having done linear simultaneous equations, hopefully you would have seen the first two videos, you'll know that you only get one value for x and one for y. So that would be your answer, literally. It's literally as simple as that. You just have to know what you're looking for, right? Now that you know that, every question should be really straightforward, some easy marks to gain in your exams, okay? Okay, the next one is similar, but as you can see now, we have got a linear graph, a straight line graph, and a quadratic, okay, an x squared. And we know that, not even just with quadratic simultaneous equations, but just quadratics in general, when we solve them, we tend to get two pairs of solutions, right? So 2 lots of x, 2 lots of y. Now, if we take the same logic we had in the previous questions, you can kind of get an idea as to why. So you can see we're looking for obviously values of x and values for y that they share in common. Now in this case, you can see there are two places where they intersect, where they cross over each other. So that's where we get our two different values of x and our two different values of y. Okay, so in this case, you just have to look for both of them, okay? Make sure you write down all four answers, not just an x and a y. Write down two x's and two y's. So in this one, we can actually see it quite clearly. So if I just look at the top one first, you can see that x is 1. So x is 1 and y is 4. And then the other one, we can see over here, we've got x is, again, don't forget if it's a negative, we've got -2 and y is 1. So it says, using the graph solve, you can see we've still got two equations here. However, only one of them is drawn. So you can see the top one is quadratic, that one's clearly drawn, right? This one is a quadratic graph, it's a U shape. The second one though, is the one that's missing, and you can see that that is a linear equation. In this case, it'll be a few more marks, I'll give you a little bit more space, because what they actually want is they need you to demonstrate that you can plot the straight line on the graph, and then we can look for the points of intersection. Because I know it's going to be a straight line graph, really all I actually need to do is plot two coordinates, and then I can just use my ruler to join them up, because it's a straight line, right? Now obviously you're looking at that going, yeah, but how am I supposed to find the coordinates of this? Well, as we said, all straight line graphs normally are in this format, or originate from this format, y equals mx plus c. What I would do is I would rearrange this, then we can go from there. So let's do that. So rearranging it, I'm going to subtract x. I need to also then subtract 10. And finally, I need it in terms of y, not 2y. So I need to divide by 2. So I've got y equals -1/2 x, and then 10 divided by 2 is 5. So I've rearranged it. What I want to now do is obviously plot it. And like I said, I'm going to choose two coordinates. So this is kind of a cheat way to do it. We should know from knowing how these straight line graph equations work that the plus c is the y-intercept, isn't it? What that means is on the y-axis, it's going to cross at -5. So the y-axis, obviously, x is 0, and then y is -5. So go to the y-axis, -5. Now I just need to choose another x value that I can see on my graph, substitute it in to find the corresponding y value, okay? So you can choose any. I'm going to choose -4. So we say, like, when x is -4, I want to know what is y. So I now know my other set of coordinates that I can use is -4, -3. So you come here, -4 along, and then -3 down. Get your ruler and draw a straight line, not just joining up the points, but extend it the whole way through the graph. So now that we've done that, we're just back to checking where do they intersect. Now, luckily one of them is actually the one that we plotted, isn't it? It's this one here, literally. Let me put up here. So solutions, we have, again, we'll have two x's and two y's because we have got a quadratic. So we've got x is -4 and y is -3. So that actually did end up being a solution in itself. And then the other one is here, isn't it? So again, this one you might want to draw some lines with your ruler so you can actually read it very well. So we can see that x looks like it's exactly halfway. So we've got, again, remember that it is negative, isn't it? So we've got x is -0.5 or -1/2 if you want to use that. And then y, let's check that one. That's -4.75, isn't it? This one though, because it's a little bit harder to read off, it might say, using the graph find estimates for the solutions. When it says estimates, it's just suggesting that the actual solutions probably have like 10 decimal places. Obviously, we can't visually read that off a graph, so you're just estimating it roughly. Also, because you've drawn your line, everyone's will be slightly different, won't they? So you will read off a slightly different value over here. So they might give you a small range of possible answers. As long as you're within that range, they know that you've done something that's basically on the correct lines, okay? That should have covered everything on simultaneous equations. Thanks for watching this video. Make sure to subscribe and leave any comments or questions you have down below.